So let's do the Farmer's Almanac question about Anchorage, Alaska and how many hours of sunlight they have. This one was on one of your handouts. It's number 4. Um, says on the summer solstice in Anchorage in 2007, there were 19.42 hours of sunlight. So if you recall, the summer solstice is on the 172nd day of the year. And on that day, they had 19.42 hours of sunlight. On the winter solstice, which happens on the 356th day of the year, December 22nd, they only had 5.48 hours of sunlight. So what I've just identified is my high value and my low value. Um, so Anchorage, Alaska, kind of a strange place, isn't it? Not a whole lot of sunlight happening there. So let's take a look at calculating our Y value first. We'll take our Y value and let's calculate that one first using our A formula. Y min, Y max. So what do we have here? We have A is equal to um, 19.42 minus 5.48 all over 2. And when I did that, I came up with 6.97. What does that represent to our problem? For our problem, that 6.97 represents for us the variation in the sunlight that they get throughout the year in Anchorage, Alaska. I'll take that and set that aside. Let's talk about B. If we're talking about B, we know for B we're going to go 2 pi over our period. Our period, how often until we get to the next summer solstice? For example, if we're on day 172, the next summer solstice happens 365 days later. So 2 pi over 365 is our period. So I go ahead, take that, set it aside, and let's go on and talk about this horizontal shift. This horizontal shift, if you can imagine at day 172, what's happening? I'm at my high point here for hours of sunlight, and we've got something like this going on. How far over do I have to move a typical cosine graph to get there? I have to move it 172 spaces. So that shift is 172. I'm going to take that, multiply it by b, which I already calculated over here to be 2 pi over 365, and that's going to equal c. If I multiply 172 times 2 pi, I get 344 pi over 365. So here I've got all my information for C. So I take that. So here we've got C. I'm going to take that and I'm going to set that aside until I'm ready to write my equation. Now let's take a look at what's happening with D. D people tend to not have too much trouble with. It's pretty much the same thing we did in A, but for D, we're going to do 19.42 plus 5.48 instead of subtracting that. That gives us a grand total of 12.45. Do you know what that means to Anchorage, Alaska? What is that 12.45 all about? That 12.45 tells us the average hours of sunlight that they get in Anchorage, Alaska. So even though they get a lot of days that have almost no sunlight, only 5.48 hours, they get more days. On average, those long days where it never gets dark are greater than those days where it doesn't. Let's write our final answer. Our final answer will say y equals, Here's my A, 6.97 times the cosine of 2 pi over 365 times x. Don't forget the x. A lot of people try to forget the x. I need to give myself some space. Whoops. And then we're going to go minus C. We came up with 344 pi over 365 plus 12.45. Here is my final equation for modeling the hours of sunlight they get. Now, if I want to take that and take that a step further and answer the question, what about February 7th, for example, or what about the equinox? What I can do, I can use my calculator to help me with that, and this ought to work out pretty nicely. I'm going to pause for a minute and get back to you. Okay, so I hit the y equals button, and with the y equals button, I'm going to type in my equation that I have over here for modeling this temperature data. So I'll type in 6.97 cosine. I'm going to put extra parentheses around my formula. 2 pi divided by 365. There's my fraction. Now I need the x minus another fraction, so another set of parentheses, 344 pi divided by 365, close those parentheses, and then close the cosine parentheses, add on my 12.45. So I've got this equation. I'm not going to graph it this time. I'm going to do something a little bit different. Since I've got this equation entered into my calculator, I want to look at a table of values. To look at a table of values, I come back up to this second button and I hit second window. Whoops, second window. There it is. I tell the calculator where would I like this table to begin. Let's begin this table at 0. We're going to increase. The triangle table means I'm going to how much we're going to increase by. We're going to increase one day at a time. Now if I find the table button, which is second graph, I get a table of XY values. Now the X values, remember, are the days of the year. The Y values are the hours of sunlight. As I scroll through this list, I can see those hours of sunlight in the Y column are increasing as I go. Now, the question is, first question was, how about the 38th day of the year? That's February 7th, on my birthday. What will it be like in Anchorage, Alaska on my birthday? Well, let's go back to my table set. And my birthday happens to fall on the, what is that, the 38th day of the year? So I'm going to have my table start at 38. Why not? That's the number I need. Now if I find the table, here I've got information about what's happening on the 38th day of the year. On the 38th day of the year, Anchorage, Alaska gets 7.713 hours of sunlight. The calculator calculated that for me. Of course, I could have done this on my own without the use of the table feature, just by simply putting a 38 where that X goes and crunching the numbers the old-fashioned way. This is kind of a nice newfangled way of going about it. If we talk real quickly about the equinox, what do you know about the equinox? Whether it is the fall or spring equinox. The equinox is the day of the year where we have equal sunlight, equal sun and dark time. Well, that would mean 12 hours. 12 hours of sun and 12 hours of darkness. So how could I use this table feature to figure that out? I could certainly use this table feature to figure that out by scrolling through those y values and looking for 12. And I can keep scrolling, scrolling, scrolling. Gosh, those numbers are going up awfully slowly. Maybe take a guess at it. Look at what's happening there. I'm at 9.5 at 56. Let's just try one. Maybe take a look at 100 days. What happens at 100 days? At 100 days, oh, went too far. I'm at 14.78. Let's see what happens at, say, 70 days. At 70 days, what happens? Now I'm getting closer. I'm at 11 points, looks like 5, 6, 7, 8. There it is, on the 77th day of the year. On the 77th day of the year, I've got exactly 12 hours of sunlight. So day 77, we have 12 hours of sunlight, 12 hours of darkness. So how about the other equinox? The other equinox, when will that take place? Well, that's going to take place, if you can imagine what's happening here. We have our sort of a zero line. This is really 12.45 hours. And what we're looking at is we're saying, well, what do we have? We know that at 172 days, we're at a high. We know that at 356 days, we are at a low. That's not a full year, right? I mean, that's not quite at the end of the year. We happen to know that here at 77 days is where we have equal hours of dark and light. And what happens here on day 0 or day 1, we're at a low again. So we need to figure out where this point is. Well, this point right here is going to be halfway between 172 and 356. So let's find out what number is halfway between 172 and 356 and add those numbers up. What do we have? We've got 528. Let's add them up, divide by 2. So grab your calculator. We'll get out of that by quitting. We will hit 172 plus 356. Divide that by 2 to get the halfway point. And we're at day 264. If I head back into my table, let's see what happens at day 264. We ought to be really close to that equinox. There it is, 267th day, very close. Remember, we've got leap years to take into account. So when is the equinox? The equinox is on day 77 and day 267. I hope this helped a little bit, walking you through one full problem. Take care. Bye.